This video is about a hypothesis test for proportion P of a binomial distribution. We are given some observed data for binomial distribution. Claim the proportion P of the group in the population. X follows binomial distribution with a trinumber n and a desired probability P0. HO, P equals P0, H1, P greater than P0, or P less than P0. We will use the definition of p-value to figure out p-value in this test. P-value is the probability of obtaining the observed results, assuming that the null hypothesis is true. X statistic equals the size of the desired group. When H1 P greater than P0, p-value equals probability of X greater than or equal to X statistic. When H1 P less than P0, p-value equals probability of X less than or equal to X statistic. Conclusion still the same. Please reject HO. When p-value is less than significance level alpha, reject HO. Otherwise, fail to reject HO. If we are in favor of the claim, we will write down enough evidence to suggest that. If we are not in favor of the claim, not enough evidence to suggest that. Let's go to guided practice 1. In a survey of 250 adults, 65 report exercising at least 5 times per week. That is n equals 250. X equals 65. This is our X statistic. Observed proportion P equals 0.26. Test the following two claims about the population proportion of frequent exercisers at a significance level of alpha equals 0.05. The proportion of adults who exercise frequently is 0.30. HO, P equals 0.30. H1. Since this observed proportion equals 0.26, less than 0.30, H1 will be P less than 0.30. Then we can define the variable. Let X be the number of frequent exercisers. Then X follows binomial distribution 250 as a sample size 0.30 as the probability of success. We are given X statistic is 65. For the expected value of X equals 250 times 0.30 equals 75. Let's sketch the diagram. 75. X is 65. Based on the definition of p-value, This is the p-value. So p-value equals probability of x less than or equal to 65. Let's go to binomial CDF. Menu 6, 5 distribution. B, binomial CDF. N is 250. P is 0.30. Lower bound 0. Upper bound 65. Enter, enter. Answer is 0.0937. Third step, draw the conclusion. Since 0.0937 is greater than 0.05 or the significance level, fail to reject HO. Let's check which one is the claim. This is the claim. Fail to reject HO means check for claim. So our conclusion will be enough evidence to suggest that the proportion of the frequent exercisers is 0.30. B, the proportion of adults who exercise frequently is 0.20. Let's write down H1, HO. HO, P equals 0.20. H1, since this observed probability equals 0.26 greater than 0.20. P greater than 0.20. Let Y be the number of frequent exercisers. Then Y follows binomial distribution with 250 as a sample size, 0.20 as a desired probability. We are given Y equals 65. Expected value of Y, 250 times 0.20 equals 50. This is the mean 50. 65, it's here. Based on the definition of p-value, this will be the p-value. So p-value equals probability of Y greater than or equal to 65. Let's go to binomial CDF. Enter, enter. Answer is 0.0127. Then we can draw the conclusion. Since 0.0127 less than 0.05, reject HO. Let's check which one is our claim. This is our claim. Reject HO means claim with this cross. So our conclusion will be not enough evidence to suggest that the proportion of frequent exercisers is 0.20.